Let's say you're trying to get a hold of your family, but they're located directly across the ocean from you, and you don't have a phone, telephone, or cell phone of any type. How could you get a hold of them? I'm Dylan Kennedy, and today I'll be talking with you about high frequency radio communications, commonly referred to as HF. HF is one of the most versatile and amazing ways of communicating over vast distances, if you know how to use it right. I personally utilize HF communications in the workplace, especially in my work in the Marine Corps, and it is certainly as astounding as it sounds going over very vast distances. First today, we'll talk about what HF is and what makes it different from other radio communications. Second, we'll discuss how HF can be used over such vast distances and why it has the characteristics that it does. And last, we'll discuss why HF is important in the present and in the future for long distance communications. So what exactly is HF anyways? Please go to slide 2 in your slideshow. High frequency is the name of the frequency band between 3 and 30 megahertz. This is shown in your slide as 3 through 30 times 10 to the 6th power. In radio system design for telecommunications, R.L. Freeman describes HF as a unique method of radio transmission because of its peculiar characteristics of propagation. This propagation phenomenon is such that many radio amateurs at certain times carry out satisfactory communication better than halfway around the world with only 1 or 2 watts of radiated power. J.B. Anderson stated in the IEEE Communications magazine in February 2012 that the lower frequencies below the HF range suffer from heavy absorption during the day, while the lower frequencies offer too small of a bandwidth. Frequencies above 30 megahertz, which is above the HF band, have much smaller wavelength and therefore cannot be carried as far of a distance. This makes the HF band the prime subject to be carried over long distances, especially in certain weather conditions. Please go to slide 3 in your slideshow. The HF band transmissions take advantage of a part of the Earth's atmosphere called the ionosphere. J.B. Anderson described the ionosphere in February of 2012. The free charges like electrons are created by ionizing radiation from the sun at different heights, typically between 50 and 400 kilometers above the Earth's surface. You can see this in your diagram. You have 4 different layers during the daytime for the ionosphere and only 2 at night. This is because during the day, with more UV rays from the sun, there is more ionization and movement of electrons in the air. That makes it a bit more convoluted in the atmosphere, which will cause refraction of those HF waves. While at night, since there's less ionization in the air, HF is not as effective at night. R.L. Freeman states that ionization of the atmosphere may also be caused by particle radiation from sunspots, cosmic rays, and meteor activity. So what does the ionosphere have to do with HF anyways? Please go to slide 4. The ionosphere refracts or bends the HF radio waves, sort of like a mirror, as you can see in your slide. The angle of the transmitting antenna, represented by T on your diagram, will determine where the HF signal can be received. Too steep of an angle for your antenna will cause the ionosphere to refract the HF radio waves into space rather than back to the Earth's surface. You can see this with the very first wave. You can see it still goes to the ionosphere, but it goes out into space. R.L. Freeman states that transmitted waves striking the ionosphere may be refracted directly back to Earth and received after their first hop, or they may be reflected from the Earth back to the ionosphere again and repeat the process several times before reaching the distant receiver. This can be seen in your diagram where it says multiple hop. For multiple hops, the Earth would require a refractive characteristic, such as with the oceans. Sand and dirt and mountainous ranges are very bad for refraction. So what would HF communications be important for in today's technology world, especially with superior technology available through satellites? HF communications is very cost-effective compared to satellite communications. Satellites require resources to allocate the channels for use. This is very expensive to order those specific channels for use on a daily basis. Because of its efficiency, HF is still the primary means of ship-to-shore communications. This is heavily implemented by the world's militaries and merchant vessels, primarily because water is a refractive element on the Earth's surface. So the HF waves are able to go much further distances over the ocean, which makes it very efficient on vessels. Although satellite communications are more reliable in most cases, HF communications can be fixed more easily by the user due to eliminating the middleman, or your satellite network. In conclusion, HF radio communications has been a mainstay of long-distance communications for many decades. It's very efficient in comparison with modern technologies. I hope you learned something during this discussion today, and thank you for listening.